Okay, this is section 7.4, part 2 video. And we're going to look at multiplying with radical terms, not adding and subtracting. Well, before I do that, let me remind you of going back to multiplying with polynomial terms. Remember that multiplication has a commutative property about it, and it's this. If I say 5 times 3x, what does that equal to? Yes, that's 15x. Now, but let me show you why. This 5 times 3x is really this. It's 5 times 3 times x. And in multiplication, since it has a commutative property, you can do it in any order that you desire. So I can do the 5 times the 3, which is 15, and that's x. Now, the next one's a little different, because it's 5x times 3x. Now, when you multiply 5x times 3x, what do you get? 15x? No. 15x what? Squared. Now, let me show you why. And I don't want you to do it this way. I just want you to write 15x squared. But let me explain why. This is really 5 times x times 3 times another x. Okay, if multiplication is commutative, that means I can switch the order around. So I can do 5 times 3 times x times x. Now, 5 times 3 is 15, and then the x times the x, if you're multiplying and the bases are the same, you keep the base and you add the exponents. Now, let's look at this next one. So if I have 5 times 4 square root of 3, this is really 5 times 4 times square root of 3. Now, I can multiply the 5 times 4, which is 20, because they're both out from under the radical, and then that's square root of 3. But if I have 5 square root of 2 times 4 square root of 3, let me rewrite it a different way. 5 times square root of 2 times 4 times square root of 3. So this would be 5 times 4 times square root of 2 times square root of 3, which is 20. Now, let's look at that. Remember when we were reducing a radical? And you got a radical, and you're multiplying two things under that radical. Like what we did in the last section. Square root of 16 times 3. You can break that into two parts and then do each one separately, because you're multiplying. Well, what I'm doing now is going backwards. This is broken apart, but you can't get the square root of either one of these. So what I'm going to do is put this back together, and when I do that, I get square root of 6. Now, that is completely different than adding and subtracting. So here's all you need to know about multiplying with radicals. You can multiply one square root times another square root, but they have to both be square roots. Now, how do I do that? When you multiply one square root times another square root, your answer will be a square root, but you simply multiply the radicands together. You simply multiply the radicands together and keep the square root. Now, if that would reduce after I multiplied them, I would still reduce it. But square root of 6 doesn't reduce. Now, does adding and subtracting work that way? No. Adding and subtracting, you never add or subtract what's under the radicals. You add or subtract the coefficients, but never add or subtract what's under there. They have to be the same in adding and subtracting. They don't in multiplying or dividing, for that matter. So, let's look at some examples then. So if I have 2 times 7 square root of 11, what would this be equal to? It would be 14 square root of 11. Or if I have 3 times the square root of 5. Now be careful right here. 3 times the square root of 5. This 3 is not under a radical, so you can't multiply it by this square root of 5. But you can multiply it by that understood 1. So it's 3 times 1, which is 3 square root of 5. Now, if this were square root of 3 times square root of 5, that would be square root of 15. You can multiply those together as long as they're both under the square root. But remember, when you multiply, the number that's under there changes. So when you finish it, always ask yourself, will this reduce? And square root of 15 does not reduce because there is no perfect square that goes into 15. Excuse me. Okay? Now, let's change it just a little bit. Let's suppose it was this. If I multiply 5 times 3 plus x, what is this called when you multiply this? What property? Yes, it's the distributive property. So this would be 15 plus 5x. Now, you can't add that together because they're unlike terms. So, suppose I have this then. 5 times 3 plus square root of 7. It's still distributive property. So this would be 5 times 3, which is 15, plus, and then 5 times square root of 7. You don't multiply that by what's under there, you multiply it by what's in front. So that would be 5 square root of 7. Now, can we add these two terms together? No, because the adding rules say they have to be like terms. So that is the answer to that problem. Now, let's go back. Let's do the one like this. 5 square root of 3 times 4 square root of 6. 5 square root of 3 times 4 square root of 6. Now, this is not distributive property. This is one term times one term. So what would this be? 20 square root of, you can multiply these two together, which would be square root of 18. But I can't stop there if this will reduce further. Well, it will. Square root of 18, 9 goes into that 2 times. And square root of 9 is 3. And then 3 times the 20 out front would give you 60. And then you put that 2 back under there. So after you multiply your radical terms together, you have to make sure that your answer is reduced. But yes, you can use the distributive property so right here, when I multiply this, this is one term times 2 terms. So it's distributive property. So 1 square root of 6 times 7 square root of 3 would be 7 square root of 18. Plus 1 square root of 6 plus 1 square root of 2 is 1 square root of 12. No, you do not have to put that 1 there. Now, can these two be added together like they are? No, because they're unlike terms. However, if these radicals reduce, I must do that. So, will square root of 18 reduce? Yes, it will, because 9 is a perfect square and it divides into it. And then square root of 12 is a perfect square. And 4 is a perfect square and it goes into 12. So square root of 9 is 3 times 7, which is 21, square root of 2, plus 2, square root of 3. That is my final answer because those two are unlike terms. Now, let's just for a sake, let's suppose this had been, don't write this down. Suppose this had been 21 square root of 2 plus 2 square root of 2. Could I have added these together now? That's if you had this. Yes, that would be 23 square root of 2, not 23 square root of 4. So after you multiply and reduce these radicals, some of this stuff still could add together or subtract together. Okay, let's do one more example. before I do this next example, let me remind you of this. How did we do this problem right here when we were doing polynomials? If you'll remember, what we did was, when you square a by, you get a try. Now, I showed you a shortcut on how to do this, but I told you if nothing else, you could square this binomial by writing it out twice and then using the FOIL method. Now, what did I tell you you could not do? You cannot just square the first term, square the last term. You have to write it out twice and do the FOIL method, or you can use that shortcut method that I showed you if you remember how to use that. Now, let's look at one more example. So, this is a binomial. So, can I just square the first one and square the last one? No. If you do, this whole problem is wrong. So, what does it mean to square something? It means that you say it times itself. Now, when I say it times itself, now I just simply use the FOIL method. So, take the square root of 7 times the square root of 7, which is square root of 49. Square root of 7 times negative 3, negative square root of 3. A positive times a negative is a negative. Square root of 7 times square root of 3. You multiply those together because they're both under the radical, would be square root of 21. Now come back here. Negative square root of 3, 1 square root of 3, times 1 square root of 7 would be negative square root of 21 again. And then negative times a negative is a positive. Square root of 3 times square root of 3 is square root of 9. Now, a couple of things. First of all, what's the square root of 49? It's just a plain 7. What's the square root of 9? It's 3. Now, I can't reduce these two radicals because there's nothing that goes into 21 that you can get the square root of. However, is this radical and this radical, are they like radicals, like terms? Yes. What's the coefficient? 1. What's the coefficient? 1. What's behind the 1? Square root of 21. What's behind the 1? Square root of 21. So what's behind this coefficient is the same as what's behind that coefficient. So that means that these two terms are like terms. So how do you add them or subtract them? You combine their coefficients. Negative 1 minus another 1 is minus 2. But you never add or subtract what's under there together, ever. It's just the coefficients. Now, when I do this, I can add the 7 plus 3. What is 7 plus 3? It's 10 minus 2 square root of 21. No, you cannot subtract those. The only way you could subtract these is if this was 10 square root of 21 minus 2 square root of 21. So this is your answer by using the FOIL method. One other thing I want you to observe is this. Notice when you took the square root of 7 times the square root of 7, which is 49, square root of 49 is just 7. So square root of 7 times square root of 7 is just a plain 7. Square root of 3 times square root of 3 is square root of 9. But what's the square root of 9? It's 3. So square root of 3 times square root of 3 is just 3. This is what I want you to see. Anytime you take a square root times itself, if it's times itself, the answer is just going to be the number that's under there. Let me show you a couple more and that'll close out this section. So if I do this, square root of 8 times square root of 8. Well, if you do it the long way, that's square root of 64, isn't it? But what's the square root of 64? It's 8. Now, when you put this 8 here, don't put the square root back over it. You took the square root of 64, which is 8. Let's do another. Square root of 9 times square root of 9. If you do it the long way, that's square root of 81. But what's the square root of 81? It's just 9. So if you want to, anytime you take a square root times itself, you could just go straight to this if you didn't want to do it the long way. So last example. So if I said, what is the square root of 73 times the square root of 73? I don't have to actually do that in my head. I know the answer, square root times itself, is just going to give you that number without the square root. But that only works when you take a square root times itself. Any other time, you have to multiply them together and then reduce the radical. So that concludes section 7.4, part 2, multiplying with radicals. And so now we will move into section 7.5 in the next section.